Good day, everyone. My name is Bill Boley. Work for Air Force Life Cycle Management Center out of the Hanscom operating location for Cost and Economics Division. I'm here to present you with Inflation, Escalation, and Data Normalization training. This training is intended to support the cost on the job training, CE cost element 2 and cost element 3 related to, again, inflation, escalation, and data normalization. This training is intended to support your learning in the field of these subjects. It is not intended to, satisfy all the requirements. You need to work with your supervisor and your chain of command regarding what is expected of you in order to achieve these elements. So here's an overview of what we're going to cover. We're going to talk about inflation versus escalation, what's the differences and why they're similar, why they're important or why it's important to understand these things. We're going to talk about base year and then year, the raw and weighted inflation indices. We're going to go over some inflation conversions. There's going to be a conversion diagram to help support the exercises later on and to help facilitate some understanding as to when to apply each of the raw and weighted inflation indices and how to apply them. There's also going to be some inflation calculations we're going to walk through as an example. Escalation calculations we'll walk through, and we'll discuss those escalation calculations and the differences between inflation calculations and escalation calculations. And we'll talk about normalizing cost data. And then there'll be an exercise. The exercise will cover all three subject areas: inflation, escalation, and normalization. We'll come back to the PowerPoint slides for the summary before concluding. Inflation versus escalation. Inflation is the overall change in the prices or general rise or fall in the price of goods or service. So we normally think of inflation as a one-way train where it only goes up, but technically inflation can come down, and in different economies it's going to act differently. So the inflation that we're going to focus on is going to be on the US dollar. So we're going to be specific to the US economy. But if you were talking about inflation of a different currency, then you would need to look at the economy of that currency. There's a lot of factors that go into inflation. The gross domestic product and the amount of debt the government's in, as well as the amount of money that's in circulation and the overall health of the economy, employment, unemployment, other benefits. There's a lot of variables that go into this. The Bureau of Labor and Statistics has a lot of data on all these economic factors, including the consumer price indexes of how much consumers pay for various products, the employment price indexes, which is how much employers pay their employees for various job sectors, the producer price indexes, which includes how much the producers of the goods and services cost them to produce. So all these different measures of the economy are used to create the inflation, or look at inflation into the future to see what the expectation is and to project that. This is all done largely by the Bureau of Labor and Statistics. They have a large team of people that works on this constantly. They produce this inflation table or inflation forecast every year for the future, and it's constantly being updated. Escalation, on the other hand, is the change in the cost or price of a specific good or service. So we do not use escalation on the total economy. We use escalation on a specific item or class of items. It includes general inflation, but it also includes a thing called real price change. So this is driven by changes in the specific good or service, changes in the product, It could include, changes in the technology that's included in the product, how customers feel about the product, the supply and demand of the product, and again, it's very specific to that product. This is where, again, the data at the Bureau of Labor Statistics has the consumer price indexes and the producer price indexes of various commodities. So that data could be used to do analysis on that specific product field in order to determine how that real price change has influenced that the growth or decrease, increase or decrease of that product's cost over the period of time that data is available. So if you think about a product in the U.S. for which prices has changed over the past few years, if you ask yourself, has the price risen slightly and constantly over year? If the answer is yes, then you're probably talking about inflation. If the answer is no, and the price has risen dramatically or actually decreased, then you're talking about escalation, because this is the reality of that real price change impacting the price of that product. And again, the bumper sticker here, a link to the Bureau of Labor Statistics website where you can find a lot of additional resources, tools, and data on the subject of inflation and escalation and indexes. Why it's important. So the cost community for the Air Force and for the DoD needs to produce reliable cost analysis. And in order to do that, we need to ensure that inflation and escalation adjustments are made so that we're requesting appropriate levels of budget or doing adequate comparisons between data we have. So you'll see here in the example, if the aircraft price today was $100 million and we assumed that there was no such thing as inflation, in 10 years from now, we would still try to buy that aircraft for $100, but we wouldn't have sufficient money for that because there's going to be inflation on the value of the dollar we're trying to use. So in 10 years from now, that aircraft is actually going to cost at a minimum $120 million because of inflation. Well, what if there's a special special part of the aircraft or several parts of the aircraft or aircraft in general or overall has a real price change as well because of supply and demand imbalances or limited resources that are needed to actually manufacture them, or a change in the manufacturing process of those aircraft. Then we've got this additional real price change, which shows the entire inflation real price change is the escalation of that aircraft. In 10 years, that aircraft could cost, $135 million. If we don't account for this, if we don't do the research now to estimate that cost 10 years from now, we could have insufficient funding, or which could lead to problems for the program, including, cancellation or having to wait in order to get more money, or other problems with having to reduce the quantities, or other impacts or corners that would need to be cut, features that would have to be eliminated, or capabilities that could have to be changed in order for us to actually afford what we wanted. And we don't want to plan on doing any of those things because we have these quantities and requirements for valid reasons, and we want to make sure we're able to buy exactly what we need for the warfighter. Again, it could be the difference between success and failure of the program. Base year versus then year. So base year is a 12-month period used as a reference against which to measure price change. This is also commonly referred to as the constant year. So this is money in any given year, but it's usually labeled as a specific year's money. So I can tell you if we have money today that it's worth the current year dollars, but we could also use that as a adjustment as a reference point for a different year as well. So say we have base year $20, you could have the same value of the dollar in 2020, but you could put that value in a different year. It just needs to be annotated that it is a base year value, what year it's the base year for, in order to make sure it's clear to the reader or to anyone receiving the data what they're looking at, that the inflation of money has not been accounted for in the presentation of that value. We do not use base year for budgeting. We use base year dollars to compare programs or to compare data points from various systems in order to have an apples to apples comparison. So when we have two programs and we want to compare or contrast um, the cost of those two programs to see which one is a better deal, we want to convert those values into the same base year dollars so that we're removing the effects of inflation, because inflation is especially future inflation is a reference to an estimate. It's an estimated future inflation or calculated. So there's always uncertainty in what the inflation is going to actually be because of unforeseen events. So we want to, take that variability out of the equation in order to have a fair comparison between those data points. Then your dollars takes into account that inflation, but it also takes into account the time phasing of the funds expended year over year. So what this means is that uh, the government, given the government process in acquiring services and goods, we ask for money in a given year for procuring something, for spending. When we receive that money or permission to spend that money from the government, we then takes us time to actually spend that money, to actually sign a contract with a contractor for some specific good or service, and then for that contractor to bill the government for that good or service, and then for us to actually pay that contractor. So that whole process, including the contracting process and everything that goes into this, the whole government acquisition process, takes time, and we oftentimes contract for goods or service that take a while to do or to make. So it may take a contractor several years to actually do what we want them to do. But we may have all the money up front to do that work for various reasons. So we do this then year conversion, which takes into account the fact that that money is not going to be spent this year. It's going to be spent, some of it this year, some of it next year, some of it the year after that. Since that money is going to be spent over several years, we want that money to maintain its value over that period of time. So we use this then year dollar calculation in order to facilitate that. We use this then year dollar for budgeting. This is how we create those budget requests that ultimately end up with the funding for these programs. Um, and again, these are done at the appropriation level. So because of that outlay profile of because it takes years to spend this money, each appropriation spends money differently at a different rate. So given that, we create a then year dollar for each appropriation. And we'll get into a little bit more details on that in the next slide. So this brings us to raw and weighted inflation. So raw inflation index, so the raw index, is the forecasted change in the purchasing power of the dollar. This is produced by the Bureau of Labor and Statistics. They provide this and update this annually, or if not more often than that, in order to provide these projections of how the value of the dollar is forecasted to change across the future. The weighted index is an adjustment to the raw index that accounts for the expected increase and decreasing of the buying power of the dollar over the obligation period of the money and the outlay profile of that money. So if we have a certain appropriation and we know that historically we only spend 60% of that money in the first year of the appropriation, and then we spend 40% in the second year of that appropriation. We're going to weight the index for the inflation on that with that profile in mind in order to make sure that 40% of the money has that extra year of inflation in order to account for that delay in the actual expenditure of that money so that the value of that dollar is still being held into that second year. And here's that example kind of laid out with two theoretical indexes. So we have a raw index for base year 15. It's forecasted to be a 1.35 in 2030 and 1.38 in 2031. The presumptive outlay profile for this made-up example is 60% in year one and 40% in year two. Again, this means that historically, whatever appropriation this is, we expend 60% of the money, meaning the contractor actually invoices us and we send them the money from the Treasury, 60% of it in the first year of that appropriation, and then in the second year of that appropriation, the remaining 40% is sent to the contractor from the Treasury as actually expended to them. Given this outlay profile, we create a weighted index for the year 2030, and it's calculated by multiplying the yearly outlay rate by the raw index. Then we add the second year's outlay rate times the raw index, and you see the equation here, 0.6 being 60%, the first year's outlay rate 1.35, add in the 40% from year two, and then we get the total amount. These weighted index tables are produced by the OUSD comptroller every year. They're published in what's called a green book. They're appropriation specific, and these are what we're supposed to use or what we're told shall be used when we do our budget requests. More importantly, these weighted indexes are also used to then remove the effects of inflation from budgeted dollars. So when we're doing analysis or comparisons between programs, we look at the then year dollar amount and then use these weighted indexes to bring those dollars to a base year, and we're going to go through some of those calculations in a minute. So for inflation conversions, these include going from base year to base year or base year to then year or then year to then year. We're going to be normalizing or converting the data in one base year to another base year. It's necessary for the analysis, like I was saying. We want to have that common base year of the two data points or more data points in order to have a fair comparison or to see what really has changed or how they rack and stack with each other for various reasons. So here's a base year to base year example. So if you think about the cost of a candy bar is relatively unchanged for the past 50 years or more. It's the same product. Maybe some of the ingredients have changed, but for the most part, a candy bar is the same as it always was. A candy bar was $1.10 in 2009, base year 2009. So if you were, around in 2009 and you bought a candy bar, that's the, typical price you would have expected to pay for a candy bar. In 1965, you would have paid 5 cents for that same candy bar. So we've got two data points, $1.10 and 5 cents. But to fairly compare these data points, they need to be represented in the same year of dollars, because again, $1 in 1965 and $1 in 2009 doesn't hold the same value. So when we adjust these values of both to the same year, we normalize them to base year 20. So we adjust the value to base year 20 instead of base year 9 and base year 1965. We then get the both prices are $1.50. So as we remove or we change the inflation and we inflate those dollars to a base year of 2020, we find that both data points actually show up to be the same value. So the dollar, the purchasing power of the dollar has changed, but the cost of a candy bar has not really changed, or the value of a candy bar has not really changed over that period of time. So it may cost more money, but it still maintained its value. There hasn't been any real price change to that candy bar. So when converting data from a base year to then year, or from a then year to another then year, which is necessary for establishing budgets, we're going to walk through examples here. So we can estimate the cost of a candy bar now in 2050. So we have, the value of two data points, and we're going to use those two data points, normalize to base year 20 to estimate the value, the cost of a candy bar in 2050. Again, if this is thinking of it as, okay, what if the government's going to buy a candy bar? Uh, so we're then going to convert that $1.50 cost from base year 20 to a then year 2050 using a weighted index. So when we convert that base year 20 value to a value in a future year, 2050, we get $3.25. If we're going from a then year to a then year, so for this example, let's assume we purchased engineering services in 2020. So if this is an amount that we obligated to a contractor, we obligated or we purchased, the government did, in 2020, $1 million in then year dollars, and we want to acquire those same services in a future years, let's say 2022, and we need to know how much to budget. We can then estimate the cost in 2022 to be 1.06 million by converting, the 1 million in 2020 to the 1.6 in 2022, again using a weighted index table. So this is just a general overview of the terms and the types of calculations that we'll be doing. In the exercise, there's going to be plenty of opportunity to do these in practice to help you get a better understanding. So here's the diagram, the conversion diagram of doing these conversions. So if you're going from a base year to the base year of the index that you have available, you're going to divide by the raw index for the year in which your data is. And again, we're going to walk through plenty of these calculations, and I did include this conversion diagram in the Excel file with the examples, the exercises, so you can reference it as needed. If you're going from the base year of the index to a different base year, then you're going to multiply by the raw index for that target year. Similarly, if you're then year dollars and you're going to the base year of the index, you're going to divide by the weighted index for each year that you have inputs. And then if you're going from the base year of the index to then year dollars, you're going to multiply by the weighted index from each year that you have inputs. And to help illustrate this a little bit even more, we've got these inflation calculations. So when you're converting from a base year to a base year, you're going to, have some index table, and you see the index table in the bottom right hand corner of the slide. This is a base year 18 index table. So this is the table that we have available. You should always be using the most recent table you have available, because the most recent table you have is the table that's been updated the most. It's got the most current information. So we always want to try to find and use the most relevant and the most up-to-date tables that we can have. For this example, we're going to be using a base year 18 index table because that's what's given. So this is what we have. You can see in the raw index column for the row FY18, you've got a 1 in that spot. This is, again, another way for you to figure out what year of that index table we're looking at. This is a base year 18 index table because if you had base year $18, they would be unchanged. They're just would be multiplied by 1. So the 1 will indicate the base year of your index table. So for the example at the top, base year to base year conversions, you see we're given base year $16 of 5 in FY16, 6 in FY17, and 8 in FY7 in FY18. Total is $18 million or $18. You see we want to convert this to base year 18 again because base year 18 is the year of our index table we're given. So we're converting from base year 16 to base year 18. Even though we've got values in the FY16, 17, and 18 columns, all those values are represented as base year $16. So again, this is where proper labeling on our charts and graphs is very important when it comes to understanding the data that's provided and how to handle it or convert it from one thing to another where necessary. So this is base year $16. So even though you've got values in FY18, in order to convert them to base year $18, we still need to divide them by the appropriate raw index. In this case, the appropriate raw index is the raw index for base year 16, which is 0.64949. So you'll see here in this example, we're dividing those values all by that index from base year 16 in order to get our base year $18. And you can check your work here too as you go. We're looking at converting base year 16 to base year 18. So we're going from the past into the future with our conversions. So we're talking about inflation. So we would expect the cost to go up because the value of the dollar has gone down over that period of time. So we do see the total goes from 18 to 18.65. So it's moving in a direction that makes sense. We're kind of just sanity checking our calculations as we go. Now we've got our values in base year 18, which is the base year of our table, and we want to convert them to base year 20. So instead of dividing, we're going to now multiply to come out of the base year of our index table. Since we're going to base year 20, we're going to use the raw index for base year 20, which is the 1.0404. So again, we're going to multiply by that value in order to get our updated value for base year 20. And again, we can check our answers by looking at it that we're moving forward in time over multiple years. So there should be a slight increase in our total value. Yeah, just once again to foot stomp, the base year applies to all years that there are dollars provided. So again, even though we've got values in FY16, 17, and 18, the final answer of this table is in base year 20. And we want to make sure we always label our tables to make sure it's clear what base year of the dollars is being provided. Doing then year to base year conversions, or vice versa, base year to then year conversions, we're going to use the weighted index for each year. So in this example, we are given a then year dollars amount of FY16, 17, 18. You'll notice here when we have the labeling for then year dollars, there's no year provided in the labeling TY $sign. And that is because the dollars are then year amounts for the year in which they appear. So the FY16 amount is a then year FY16 amount. The FY17 amount is a then year FY17 amount. the 18 is an FY18 then year dollars. So the then year dollars always implies that the value of the dollar is the year in which it appears. So in order to convert those then year dollars to base year 18 dollars, the base year of our index, we now need to look at the weighted index for the year in which the dollars appear. So you see in the FY16, we're going to use the weighted index on our table for FY16, 0.976882. For FY17, we're going to use the weighted index for FY17, which is 0.99467. And for FY18, we're going to use the weighted index for FY18, which is 1.013514. So again, when we use weighted indexes, we're going to use the index from the year in which the dollars are placed. So where they are, what fiscal year they are, is very important to what index year we grab. So using those weighted index amounts, we can then divide in order to get our base year $18. And now we have the base year of our index table. We've got the dollars in the base year of our index table. So to get out of that index to the then year amounts again, we would multiply by the weighted index for the target year. So since we're going to FY16, we're going to use the weighted index for FY16. We're going to FY17, the weighted index for FY17, and so on. And you can see that here. So again, then year conversions uses the index based on the fiscal year in which the dollars appear. For escalation conversions or escalation calculations, the conversions are done, or the actual math is done exactly the same as it is for inflation. There's no mechanical difference in what index to use. The only difference is the table in which you're provided. Escalation index tables are specific to a commodity, so you only want to apply the index escalation the escalation index to that specific commodity or the specific elements in a cost estimate that are part of that commodity. So you're not going to apply your escalation index table to your entire top line number. You're going to apply it very pointedly towards the things that fall under that commodity type or that specific commodity. There is analysis that needs to be done in order to build an escalation table. So that is a separate, more detailed training about escalation index tables and building them. But there's things like supply and demand and comparisons that are made in order to account for these. It's also important to note that your escalation tables aren't always positive in their trend lines. So you'll see here at the bottom center, I've got two example index tables, escalation index tables. So one's for labor and one's for IT equipment. So you see the labor has got an escalation rate of 2% annually, whereas the IT equipment has an escalation rate of negative 1%, meaning it actually goes down over time as opposed to up. Because IT equipment is actually getting cheaper, not more expensive, unlike the value of the dollar. So again, and there's just a comparison chart here as well, just to kind of illustrate, if you don't take escalation into account, we could be dramatically underestimating. Again, depending on how far into the future we are estimating these things, we want to make sure we account for these as best we can. Next topic here is the normalizing of cost data. In order to provide quality decision support, we need to have a consistent data set to make our comparisons in order to help facilitate the calculations necessary to make forecasts in order to support decisions or to help inform decisions that need to be made. This process is called normalization. That includes everything we've already talked about, adjusting for inflation and adjusting for escalation. Those are normalization types of things. Those are financial normalizations, so converting to a common year or base year, converting to equivalent units. So we're not comparing dollars K to dollars millions or dollars to dollars millions or dollars to euros or something like that. We want to convert these values all to the same measuring stick of finance. Um, we also want to include common contexts, right? So if we're comparing labor rates, are they, direct labor rates? Do they include overhead? Do they include fee? We want to make sure that, again, we're comparing apples to apples. We're not comparing a labor rate that has no fee included to a labor rate that does have fee included, because that's not really a fair comparison between the two and won't lead to good decisions. Sizing normalization. So this is where we want to convert to a common unit of measure for things that aren't financial. So if we've got some weight measurements in pounds and ounces, we want to convert those to a common measure, whether it's pounds or ounces, doesn't matter. We just want to make sure we convert the data we have to that same unit of measure. If we have software lines of code or software function points or some other measure of software productivity, we want to convert that productivity to a common unit. So again, we can compare and contrast the two the data points. Um, if we have data from various programs, we want to bucket them or group them together based on similarities. So if we've got ships, the cost of building ships, we want to put those together. If we've got cost for producing satellites, we put those together. Communications equipment, we put those together, and so on and so forth. We don't want to have, data sets where we're comparing the cost of a ship to the cost of a satellite, because those things are so different that comparison is not really a fair comparison. Um, Next is manufacturing technology normalization. So this is one of the most difficult parts of normalization and requires a lot of research potentially to get right. But this is where we would be adjusting data, for the impacts of learning curves, depending on, what information we have, what data we have. If we want to adjust for learning and look at the theoretical first unit cost of two different production lines, we would need to, make some adjustments to the data for the learning, again, based on what information we have. Adjustments for different types of technology. So the example here is comparing an iPod Classic to an iPod Nano, where the iPod Classic uses an internal rotary storage drive, which has moving parts. It's got a storage disk that moves, that spins really fast, and a mechanical arm that goes over that disk in order to read the data off of it. Whereas an iPod Nano has got a solid state storage drive where there's no moving parts. It just has the data stored and accessed electronically. So there's differences in those technologies, which is why there's a price difference in the product and a capability difference in those products, where the iPod Classic has a substantially more storage, but it also has a different reliability because of the moving parts, and also a different size and weight because of the size and weight of that internal storage drive. iPod Nano, much more compact and small, and has much higher reliability because it's got no internal moving parts. But it also has a substantially different amount of storage capability. And that all comes back to that technology. And if you wanted to normalize the data for that technology, it would require some research as to what those technologies cost and how that cost should be normalized. Last thing on this slide here, work breakdown structures. So For our cost estimates, we use a work breakdown structure. This breaks the cost down by categories in order for us to account for all the different piece parts of a task or a program in order to make sure that it's fully captured. Different programs will have different work breakdown structures, and we need to be able to compare those things even for programs that are for the same commodity. For example, if you had two radar programs, one radar program may have a subcomponent or a work breakdown structure element that the other program didn't have for some reason. Maybe one was portable and one wasn't portable, so there was some capability difference, and then there's going to be a work breakdown structure element that's not in one but is in the other. So removing the cost for that portion of the system would normalize the data so that you could then compare the cost of those two systems together in a apples to apples fashion. You could also look at, the work breakdown structure dictionaries with elements for various programs. Again, to remove anything that may be inconsistent between the two. Maybe two programs have wildly different definitions of what's included in certain elements, and understanding that is an important part of making a fair comparison. So now we're going to jump over to Excel to work through the exercise. Okay, here we are in the Excel exercise. This Excel sheet is available on the OJT SharePoint site for LCMC that you should have access to if you support LCMC, Air Force Lifecycle Management Center. If you need to find access to this, please reach out to your supervisor or your functional chain of command, and they will know who to contact in order to get this Excel file available to you. For this first example here, we're going to walk through the inflation exercise. There is a separate tab for the escalation and a separate tab for the normalization. For each of these, you'll find that there's going to be some given information. For this first one, we've got some FY or base year 18 inflation tables that are provided. Again, we've got three inflation tables here, one for three different appropriations: 3600, 3080, and 3400. There's also some given program data available here. Again, we've got separate appropriations. It's a portfolio of programs, and we've got the total cost for these three programs provided in various types of funding. So we do. It is not recommended to ever produce a chart with multiple types of funding in it like this, again, because comparing any of these numbers in this chart is not beneficial to the reader. So the first thing we want to do, and step one for this exercise, is to convert the given program data into common base year 18 data. Again, that's the base year of the table, base year 18. So we're converting program X from base year 14 to base year 18. So in this graphics over here, so we can look at it and say we're going from base year 14 to the base year of the index, which is base year 18. So we're going to divide by the raw index for the year. So in this case, we're going to divide by the raw index for 14. Again, this is 3600, but you'll notice here that the raw indexes for all these appropriations are exactly the same. Again, because those raw indexes do not take into account the outlay rates. The weighted indexes are different because each appropriation has its own outlay rate. So you see here for this program X, we're converting all the data in all these years from base year 14 to base year 18. What this means is that this index here is actually going to be used for all these years. So in order to make this a little easier, we're going to lock that cell reference. To do that, if you click in your formula bar while you're on the calculation, the formula here, and you press F4, it's going to add these dollar signs to your cell reference. What this does is it prevents this cell reference from moving either across your columns or your rows, hence the dollar signs between the columns reference and the rows reference to column and row number. So now when you can drag this formula by going like this, you'll see that that cell reference has not moved, even though this cell reference has. So we're grabbing these as we move across, but it's going to stay on this one the whole time so that you can quickly complete this. For program Y, we are we're looking at then year dollars, so we're going from then year's dollars millions to base year 14. So we're given then year dollars, we're going to divide by the weighted index from each year of the inputs in order to get the base year. So for this one, we are going to take this value and divide by the weighted index for the appropriation 3080 for the fiscal year in which we're in, which is 2014. And for this one, since we want this to take the index for the year in which the dollars appear, we're not going to lock that cell reference. And then when we drag this formula, we'll see that that cell reference has also dragged. So we're still referencing the proper year, FY16, for the FY16 amount. So again, to facilitate quicker working through this exercise. So I will, from there, what you need to complete this step 1, work into step 2, which is going to then take this base year 18 results and then convert them to base year 17. This could be needed for some comparison to the original acquisition program baseline or some other comparison that's needed for the program to compare to a different program, which is in base year 17. And then the third step here is going to convert your base year 18 amounts to then your dollars. It's important here for step 3 that you're taking your base year of your index, which is 18, which will come back to step 1. So you're going to take your step 1 values and you're going to bring those into then your dollars. Once you've completed those tables, you can then answer these questions, which is what's the total cost for this portfolio in base year $17, and then what's the portfolio budget authorization total amount. Once you've completed this, you can move on to the escalation exercise. For the escalation exercise, again, we've got some given escalation index tables. We've got the labor, we've got IT equipment, and we've got aircraft. And we're given some program information. So we've got program JK, and we've got the total annual cost of labor. We've got some material IT equipment, and we've got some aircraft material. So we've got cost laid in for these commodities, and you need to, like the previous exercise, normalize this data, which is given in various types of base year, into the base year of the index table. You'll notice here that we've got a different index table year. So this is a base year 21 index table. You'll also note here that the raw index for these 3 commodities is different. And again, that's because we're talking about escalation, and the raw escalation of these commodities is different. So we can apply the correct table to the correct line in our program data in order to get the base year 21 values in the step 1. And then we can convert that base year 21 data into then year data in step 2. And then we can go back and answer these questions, the total cost in base year 21 and the total budget authority for the program. Again, you have this graphic here available if you need. the last tab here is the normalization exercise. So for this one, you'll also have some reference information. We're going to have a little bit more information here, and this is going to kind of, tie everything together for this training. So we've got inflation tables. Again, we've got the appropriation specific tables, and then we've got one escalation table specifically for software labor. We also have some additional reference data here regarding software lines of code. So we've got a productivity rate here of 11 lines of code per hour. We've got a labor rate for software given in base year $17 of $150 per hour. And then we've got a ratio of software lines of code per function points. So if we need to do conversions here for software lines of code based on inputs we receive by function point. Also, just a statement here regarding radios, which will become more relevant as we walk through the exercise, that radio 6 and 7 are exactly the same, except radio 7 uses a solid state drive and radio 6 uses a rotary drive. That's the difference that we kind of talked about with the iPods. Given program data, so for program A, we've got software lines of code, function points, and then a base year $14 K for our elements. We've got 3 software development elements, and these are given to us in lines of code and function points. Program B, we've got radios, 2 different kinds of radios, given 2 different kinds of dollars, and then a couple of support elements as well. Program C, we've got various sustainment activities, and again, take note of the type of dollars we're talking about, and also note that we've got different appropriations over here as well. Next, we've got a work breakdown structure dictionary. So this is going to be relevant as we work through answering the questions at the end of the exercise, where we've got the prime issue product, which has got 3 sub-elements of software, hardware, and sustainment elements. Then software has a definition, hardware has a definition, and so does sustainment. We've got a fees element, which includes licenses and access fees. And then the other government cost element, which includes things like system program office support, program management administration, and direct mission support. So again, this dictionary will become relevant as we work through the questions at the end of the exercise. So step 1 of this exercise is going to be, converting program A to dollars millions. So you'll remember programs A was given to us as software metrics. So we've got software lines of code and function points here. We need to convert those inputs to hours. So we're going to convert them using the data that's provided. So for example, we're going to look at this element, which is provided in lines of code, and we have a productivity here of lines of code per hour. So if we divide the total number of lines of code by the productivity rate, we'll get hours. So we've got a number of hours that's required to do that. Similarly here at the third element, this one was provided as function points. So for this one, we're going to look at function points. Let's see, it doesn't start till 19. So over 19, and we look at the function points. And since we need to convert this function points to line of code, we know there's 50 lines of code in each function point. So if we multiply function points by the total number of lines of code, and then that'll give us the total lines of code, and then we can divide that by this productivity rate, and that'll give us our total hours for that element as well. And again, you'll need to convert all these in order to move on to the next part, which is then to dollarize those hourly inputs. Again, we now have hours. We have an hourly rate up here at the top of $150 an hour. We can use those two to calculate that cost. And then we'll be able to start continuing to normalize this data for common values. Again, this is dollars. We want it in dollars millions. And then we can move on to normalizing to common base year of all the programs. Important to note here, I have highlighted the elements, the rows that are going to need to use the escalation index just to help you get through the exercise timely. And then once you're done with all these steps and the data normalization, you can then move to answering the questions. And here are the questions. The total cost in base year 18 for program A, a ratio comparison between other government costs and prime mission product. So again, we'll want to look at what's included in those elements in order to make sure we can grab that right ratio. We've got a question here about program B. It needs to buy 5 more radios for a customer, and they want the cheapest option, and they do not require solid state drives. So which radio should they buy? This is where we would want to look at the cost of those 2 radios. You'll see that this program data was also includes quantities. So we want to normalize the data based on the quantities that were purchased in order to get a per radio price in order to see which one is more affordable to help facilitate that, supporting that decision. Then a follow-up to that is how much should that they budget if they're going to purchase that radio in FY20. And then a couple more questions about other government costs to prime mission product ratio, total budget, and again, that ratio. So if you can go ahead and pause the video now and work through these exercises. I will put a time marker, a timestamp in the comments to this video. So if you do need to exit out of the video and work on this over a period of time and then come back to the video, you can reference the comments section of the video in order, or the description of the video, in order to get a timestamp to where I'm going to go over the results of the exercise. Okay, welcome back. Hopefully you've worked through all 3 exercises here for inflation, escalation, and normalization. And now I'm going to just walk through the results here, walk through the how-tos of this exercise to give you the conclusion of this. Just make sure you got the right answers. So for this first one, for the inflation exercise, I already provided some of this information. If we get program Z here, which is already in base year 18, so converting it to base year 18 would actually just be dividing by this raw index from 18, which is 1, so there's no change to that. So if we just enter this, we can grab all 3 of these. And for step 2, we're going to convert our base year 18 results from step 1 into base year 17. So we're going from the base year of the index table to another base year. So we're going to multiply by the raw index for that target year. So we're going to select this, and we're going to multiply by the base year 17 raw index. So base year 17, 3600 for this one. And the next one is base year 17, 3080. And the last one is base year 17, 3400. And you'll see here, if you drag these formulas over, you're going to get some zeros in here when you shouldn't have zeros, right? And this is because, and this is why, we want to check our data, we want to check our work, right? You see something that doesn't make sense, right? We've got values in here, and we've got zeros in here. This is because we didn't lock the cell reference here. So for when we're doing these calculations, and again, this is why it's important to check our work as we go. We want to multiply by the year, target year for each year. So this entire table is in base year 18, and this entire new table is going to be in base year 17. So this cell reference here, this FY17 reference, is going to need to be locked in order for us to get the proper calculations, because we're going to use that same cell reference for all of them. You see here that this reference slid as the formula was dragged, and now it's off the table. And that's why we've got incorrect results. So once we have all those locked, we can actually drag all of them together. And you see here, now we've got results that kind of make sense. We can check them against our previous step. We had base year 18, we went to base year 17, which means we went backwards in time. So we would expect the cost to go down. And we see a slight decrease in all three total values, which makes sense. So we feel confident that we've done it correctly. Now we want to convert our base year $18 into then year dollars. So for here, again, we need to remember we're selecting our base year 18 values. So we want to jump all the way back up to step 1 and select these values. And we're converting it to then year dollars. So we want to use the weighted index. So we're going from the base year of the index to then year dollars. We're going to multiply by the weighted index for each year, starting in 2014 or FY14. So we're going to multiply by 3600 FY14. And for Y, program Y, we're going to do 3080 FY14 weighted. And lastly, for program Z, 3400 weighted. And in this case, we do want these equations to drag. So we do not lock the cells. And again, you can check this cell references here to make sure you're grabbing the right years in your calculations. So now we want to move on to the questions. So the total cost for base year 17. So this one is pretty straightforward. We've got base year $17 millions. Step 2 was in base year $17 millions. Total cost here is total. So there's our answer for question 1. Question 2 is asking about budget authority. So budgets are done in then year dollars, as we reviewed as part of the training. So we want to make sure we grab the then year dollars amount to show the budget amount, which is down here in step 3. So there you have it. Hopefully you got those right answers, and if not, you understand why, and you can work through getting those corrected. Now we'll jump over to the escalation exercise. So here, again, we've got for step 1, normalizing to the base year of the index table, base year 21. We've got annual cost for labor. So let's see, we're going from base year 18 to base year 21. So again, we're going to divide by the raw index for this specific commodity, which is labor, in FY18. And since we're converting from a base year to a base year, we want to lock in that cell reference. so that it doesn't drag with the formula. For the IT equipment, we're going to be converting from base year 20 to base year 21. So again, we're going to grab this and we're going to divide by base year 20 for IT equipment. And again, we're using the raw index, base year to base year conversions. And for aircraft, it's going from base year 19 to base year 21. So we're going to grab the FY19 raw index and make sure we lock that. Let's see, I forgot to lock this one. That one is all set. Okay, so now we can drag these over. And if you did drag for this part, if you didn't lock those cells and you dragged them over, you're actually going to get an even more obvious error because you're dividing, and you'll be dividing by 0 once you fall off the table. It'll give you an actual error message as opposed to just incorrect results. So it's a little bit easier to identify in that scenario, but we want to, again, just double check our data, double check our calculations, that they seem reasonable, to just check to make sure we're not making any big mistakes as we go. So again, labor, we're converting from base year 18 to base year 21. The labor index is positive, so we would expect the value to increase. So we go from 143 to 152, so that makes sense. IT equipment, we're going from base year 20 to base year 21. We now have a negative escalation rate, so we would expect that value to actually decrease as we move forward in time. And we do, we're only going forward 1 year. We only decrease by 1, so that makes sense. And again, you can check the aircraft as well. So next step here, we're going to now take those base year $21 and escalate them to then year dollars. So if we take our base year from step 1, and we're going to go from the base year of our index into then years, so we're multiplying by our weighted index. This is for labor 2018, so we're going to grab the weighted index for labor 2018. We've got IT equipment, which is going to be IT equipment weighted FY18, and we've got aircraft material times the weighted index for that one. And again, we're going to let this drag over because that's what we need to do. And we see here that we're dragging appropriately. And we can also see here we've got some calculations. You know, this comparison gets a little bit more complicated as we look at, because some of these are going to change more than others depending on what the escalation rate is. But these results look reasonable. So now we can go to the questions. So what is the total base year 21? Again, that was step 1. So we've got the base year 21 total for program JK. And program JK budget authority, again, is going to be the then year dollar conversions. So you'll see here that your actual then year or budget authority or then year dollar total is actually less than your base year $21 total. And if you look at the spread of the total dollars in the program, you'll see, if you look at this is base year 21, you'll see that the majority of the cost is actually before this base year 21. So when you convert these then year dollars to base year 21, you're actually increasing them. So the majority of the cost is before this base year, therefore it's being increased when it's converted to the base year. So this actually does make sense in this particular scenario. because of how this cost is phased over this period of time and what specific base year we're looking at. But like all calculations and all the things involving human input, we should always be checking our work to make sure that we're doing things that make sense and that come to reasonable conclusions. Okay, moving on to the normalization exercise. So again, this is going to be the longer of the three. And we've got, start right down here with step one, where we're converting software lines of code and function points into hours. So again here, we've got this reference cell of C7. It references that the conversion rate. So we do want to lock that in because we don't want that to drag when we drag this. We can just drag this all the way over and it converts all of our data. We know that the next program here, operations software development, if we scroll up, is also in software lines of code. So the equation is the same for that one. So we can drag this down as well and it'll convert that data. And for this one, software interface, we've got function points. Again, we need to lock in these references, insert those to lock those cell references, and then we'll be able to drag this formula over as well. And now we've got all these in hours. Step 1B here is to then convert those hours into dollars. So we're going to multiply the total hours by this hourly labor rate in order to get that. And again, we're going to lock that cell reference because that labor rate's not going to drag. And then we'll be able to drag this formula right over and down to get all those calculations in there pretty quickly. And this last one, other government costs, was already provided in dollars, so we just need to bring it down here to round out our table. But again, it's important to note that this was in base year $14K as opposed to base year $17. Last part of this first, which is again just to convert it all to dollars millions. We're not worrying about what year it is yet. We just want to make sure we've got everything in dollars millions. We've got dollars here, so we want to just divide by a million to get dollars millions. And that's going to apply to all three of these top rows. And then this last one was provided in dollars K, so we're going to divide by 1,000 to get dollars millions, and that's going to be the same for this entire row. So now we've got, these all these elements converted from software lines of code and function points into dollars and then into dollars millions. So we still have a couple of different types, different years of dollars millions, but at least they're all in dollars millions, it goes a long way and as far as moving towards comparing them. Step 2 here is to normalize all the data, all the program data to a common base year. So now we've got this base year $17 millions, and we want to convert it to 18. And again, you'll see here, we're talking about software development. So this is software labor. So we want to make sure we grab the escalation index when we're doing the conversions for these elements. So we've got this software development costs. And since we're going from a base year to the base year of the index, we're going to divide. And we want to make sure we grab the escalation index. And since we're going from base year to base year, we're going to use the raw. So we can come up here and we're going from 17 to 18. So we want to use 17 raw index for this software labor. And again, we're converting all these the same, so we can go ahead and lock that cell. And this same conversion is going to apply for this whole row and these rows as well. So we can just drag that down and make sure we have the same references, right? You can double check your work again just by spot checking a formula. This is grabbing the right reference cell here for interfaces. And if you go up to the top, you can see that it's still grabbing the correct cell reference for the index software, for the escalation table raw. So we're confident that that's doing the right calculations. For this other government cost, we now have a base year 17, 3,600. We're going to divide by the base year 14, base year 14, 3,600. We'll scroll all the way up, base year 14, 3,600. And we're doing base year to base year, so we're going to lock that in and drag that over. Moving on to the next one, we've got radio 6. So let's see, we know we want to convert that to base year 18. So let's see, radio 6 is provided in then year dollars. So we've got our then year dollars and we're converting it to the base year of our index table. So we're dividing and we are going from then year to base year. So we're going to use a weighted index for the fiscal year in which the dollars appear. So in this case, we're looking at 2015. Again, note that it's 2015, even though our table starts with 2014. So we want to make sure we're grabbing the correct year. We're looking at 3080. So we want the 3080 2015 weighted index. And since we're doing then year to base year conversions, we're going to use the index from the year in which the dollars appear. So we're going to let that slide over as we drag that formula. So for the next radio, we're looking at base year $20K. So we're going to take these results and we need to divide, since we're going from base year to the base year of the index, and since it's going from 20 to 18 and it's 3080, we're going to look at the 3080 section and we're going to find the raw index for FY20. So again, we're doing base year to base year, so we're going to lock that cell reference. And this is actually provided in dollars K, and we want to convert that to dollars millions. So we're going to look at this, and we can, there's a couple different ways you could do it, but if we're going to look at this total result and then divide that by 1,000 in order to convert that resulted conversion to dollars millions. Okay, and the next one is Program Management Administration, PMA. Again, this one's in then year dollars and 3080. So we're going to divide 3080 FY15 weighted index. Again, then year conversions, we want to use the index from the year in which the dollars are present. So we're going to let that slide. And direct mission support, also in then year dollars. So it's going to be the same with FY15 3080 weighted index. And of course, you can do one by one and calculate it and then drag it over and in order to check your answers one by one if you like, or you can do them all and drag them all. Okay, for program C, go up to our table. Program C, we've got data networking accessing fee in base year 17, 3,400. So we're converting into base year 18. So we're dividing that result by the raw index for 3,400 for 17. And it's base year to base year, so we're going to lock that in. For radio operations, we're going from base year 16 to base year 18, so we're going to grab the 3400 raw index for 16. Again, we're going to lock that in. Software maintenance is presented in then year dollars, so we're going to take this and divide by the weighted index for 3400 in the year in which it appears, so 15 in this case is where we're starting. So 3400 FY15 weighted index. And since this is a then year to base year, we're going to let that slide. So we're not going to lock that one. And lastly, SPO support is going from base year $18 millions to base year $18 millions. So we actually don't need to do any conversions for this one. But if you did want to just go through the mechanics, you're going to end up with a base year to base year conversion, dividing the results by 1. You're going to lock that in because it's base year to base year, and it's going to make no difference. We drag those over. Okay, so now we've got, oh, look at this. I've overlooked my escalation. So I grabbed the wrong one here. So we can fix that real quick. So this actually is software maintenance is a type of software labor, so we want to make sure we're grabbing the appropriate reference. So let's see. Go here, go here. And you see here we're grabbing 3400 when we should actually have this software labor grab. So we can go over to this cell here and we can actually drag this reference cell to the appropriate place. And it automatically updates here. And then we can just drag that updated formula across to get that correction. There we go. And you can check that. And that makes sense. Okay. So again, this is why it's important, check your work, make sure you're doing things correctly, label things where appropriate so that you've got those reminders in place to do things a certain way when appropriate. Okay. So now we go to the next part of our step 2, which is converting these base year $18 to then year dollars. So now we've got everything in base year of the index, base year 18, and now it's just a simple conversion into then year dollars. We're going to grab our software development, again, which is going to follow the escalation tables. So we're going to multiply by, since we're going from the base year of the index table to then year, we're multiplying by the weighted index, in this case for software labor. And we're starting, again, it's important to remember, we're starting in at 2015. So we're going to grab that 2015 rate, not the 2014 rate. And for this one, this same reference, this cell reference here, it needs to slide across our columns. But we also can use that same reference down 2 rows. So in order to drag this formula so that the cell references slide with the columns but do not slide with the rows, we can use the dollar signs only specifically on the rows reference. So if you hit F4, it puts the dollar signs on both of them. But if you continue to hit F4, it cycles through your options regarding where the dollar sign is. So this is telling Excel that the column reference, the G, is allowed to slide with the formula, but the cell reference 18 the row reference 18 will not slide up and down with the formula as it's dragged. You can continue to rotate through and lock only the columns and not the rows, or again, it goes back to nothing. So we want to lock the rows, but not the columns. So we want to have it look like this with G $18. And you'll see here when we drag this formula down to, that G18 does not change. It's still G18, but when you drag it over here, you'll see that the column reference has changed. It's slid with the formula. So for the next element here, we've got other government costs. And we're looking at 3,600 base year 18, and we're converting that to then year dollars. So we're looking to grab the 3,600 weighted index for FY15, 3,600 weighted index FY15, and we're going to let that drag. Radios, we've got 3080. Weighted FY15. And again, we want this to, we can drag this down, but we don't want it, we want to let it slide as we go across the columns. So we're going to just lock the row reference so we can use it on all these, and then we can drag it across this entire section. Again, you can see how this really can help speed up doing some of these conversions and charts and Excel work. Program C, we've got 3,400. We're going to multiply 3,400 FY15 weighted index. And again, we're going to lock this reference, but only for the rows. And then we can drag this down, but we do need to go back and make this adjustment here for this cell reference, because this is actually a software maintenance, which is going to fall under that escalation. So we can click on that cell, come up here and adjust this to our software labor in order to make that correction. And you'll see here that this little green triangle has shown up. And this is because you had the same equation in all these cells, and now this equation is different. And Excel is just letting you know that you've got a different formula in this cell from the other ones next to it, just to make sure that you did that on purpose. Excel doesn't know if you do things on purpose or accident, so it just gives you this error message. And we know we've done this on purpose, so we can just ignore this error. And we can drag this over. And you'll see it continues to give you that error message across all these. And if it bothers you, you can certainly clear this out. This is something, if you were going to cut and paste this chart into a briefing or something, you would want to make sure you clear out those green triangles before that, because they will cut and paste with the image, and you don't want to put those into a formal briefing content. Okay, so now we've converted all of our data into then your dollars as well. So now we can move on to step 3, is that using the tables we've created and these conversions and all this normalization we've done, we can now go to answer the questions. So the first question, what is the total base year $18 millions cost for program A? So program A, base year $18 millions. So again, in this first step, we converted it to dollars millions, but this is not base year 18. And step 2 is where we converted these to base year $18 millions, and the program A total is here. So this is our answer. what is the next question? What is the other government cost to prime mission product ratio for program A? If we look at program A here, we'll see we've got these WBS elements where we've got 3 different software development elements, and then we've got an other government cost. So obviously the other government cost is the other government cost element. But what is the prime mission product element as part of this ratio we want to calculate? So if we come up here and look at our dictionary, you can see that prime mission product includes software, hardware, and sustainment elements. Software includes all software development efforts for communication, operations, and interfaces, coding, building, and testing of that software. So we know that all 3 of these elements, which are software development efforts, all fall under the definition or the WBS element prime mission product. So we're looking at the ratio of this element to all 3 of these elements. So we can go ahead and do that calculation in here, which will be the total other government cost. And again, when we're looking at these comparisons, we want to make sure we're grabbing the appropriate normalized data. So we're looking at a comparison. We're looking to make a ratio. In order to have that be as accurate a ratio as possible, we want to use normalized data to a base year. So we're going to use this base year 18 normalized data to do that comparison. So we want the other government costs divided by the total of these 3 elements. And just a simple equation can do that for this. And this gives us our ratio here, 23%. So that's to say that our other government costs are 23% of the prime mission product. So for program B, needs to buy 5 more radios for a customer, and they want the cheapest option, and they do not require a solid state drive. Which radio should they buy? So we're looking at 2 different radios. We've got radio 6 and radio 7. And we want to figure out which one has the better unit price. So if we want to look at the unit price, and we're going to do a comparison, and we're trying to be as apples to apples as we can be. Again, we want to use base year dollars for this comparison. So if we look at the base year 18 millions, we've got radio 6 and 7. The prime mission product is the cost of the radio. We've got 2 amounts here, but we need to normalize these data points for quantities. So we can go ahead and reference this total for radio 6. So we want to grab the total cost for radio 6. And since we know that there's 20, we want to normalize that total cost for the quantity to get the appropriate unit cost. So we're going to divide by 20. And again, since we grabbed the base year $18 millions amount, we want to make sure we just label this base year $18 millions. Again, just to make sure it's clear how this is being represented. And for radio 7, we want to do similarly. We want to grab our base year 18, radio 7, total cost, and divide by the quantity for this radio, which is 28. So now we've got, the base year 18 unit prices for those 2 radios. We do know that there's a technical difference between these radios. This technical difference, based on the information we're given, is not a discerning factor. We don't necessarily care about this, so that should not impact the choice or the decision, so we don't need to necessarily take that into account. They only are concerned with which one is cheaper, and in this case, the radio 6 is the radio that is less expensive when we compare them. So we're going to recommend radio 6. So now the next question is, how much should this program budget for 5 additional radios, assuming that they're buying that Radio 6 that we recommended in the previous question. So now we need to convert this Radio 6 cost to extend it to 5 additional units. So if we have 5 units, so now we have, again, the base year $18 millions for 5 units. And since they're budgeting for this in FY20, we want to make sure we inflate these base year $18 because they're not going to budget in base year 18. They're going to budget in then year dollars. And specifically for this exercise, it's going to be an FY20 dollar amount. So if we take the base year $18 amount, and again, we're talking about radio, that's 3080. And we want to bring it from the base year of the index to then year dollars. We're going to multiply by the weighted index for FY20. So we can come up here, 3080 weighted index FY20. And that'll give us the total amount they should budget in FY20 to buy those additional 5 radios. Okay, next question is, what is the other government cost to prime mission product ratio for program B? And again, let's scroll down and look at program B's work breakdown structure. We've got 2 radio elements, a program management administration, and direct mission support. And we can go back to our dictionary and we see under hardware, this includes all radio material and assembly. So the radios fall under hardware, which is part of prime mission product. And you'll see under other government costs, program management, administration, and direct mission support are elements under those. So then we can, again, make sure we're using the base year dollars when we're doing ratios and comparisons. So we want to look at the ratio between other government costs, which is going to be the sum of our PMA and our DMS. And that's going to be divided by the prime mission product, which is going to be the sum of the 2 radios. And look at that, we've got, again, 23%, slightly different than the other program. Next, we've got what's the total budget for program C. So again, we're talking about budgets. So budgets are always done in then year dollars. So the total budget for program C is going to be down here at the bottom where we're in then year dollars. Program C total, it's right here, and there we go. And the last question, what is the other government cost to prime mission product ratio for program C? So we can look at program C's work breakdown structure. We've got data network access fee, radio operations, software maintenance, and SPO support. So if we go back to our dictionary, we'll see that sustainment includes radio operations and software maintenance. So those both fall under prime mission product. License and access fees fall under this fees category, which is not included in prime mission product or other government costs. So any element regarding licenses or fees should be excluded from this ratio. And system program office support is another government cost category. So let's see. Again, we want to make sure we're doing a base year 18 comparison for this. We're going to look at the ratio between SPO support and the sum of our radio maintenance and software maintenance, radio operations and software maintenance. And that should give us our ratio for this element. And you'll see this is different than the other two. And again, now we can make sure we can compare these things because they're using the same dictionary to explain the same ratio, and now we can look into why there might be this discrepancy in this ratio. So there you have it. That's all of the questions answered. Hopefully you got these answers, and if not, you understand a little bit as to why, and you're able to work through that. And let's jump back to the slides. In summary, inflation is the overall year-to-year change in the value of the dollar. Again, this is top-level economy-wide type of thing. Escalation is always specific year-to-year change for a product or a service. So again, it should always be labeled what the commodity is, what the product or what the service is that escalation rate is for, in order to make sure its application is done properly. Raw indexes are used for base year conversions, which is important part of comparisons and doing cost analysis. Weighted indexes are part of the then year conversions in order to use those conversions, those then year dollars for budgeting. We only budget in then year dollars. Data normalization is a very important part of ensuring apples to apples comparisons, which is an important part of having a solid decision support analysis or comprehensive cost analysis in order to support your programs. Including the appropriate inflation or escalation is a critical component to setting realistic budgets. Obviously, if you don't include it, if it's excluded or ignored, it can be devastating to the program when they go to execute and have insufficient funds. It's also bad the other way as well. If you are over capturing escalation on something that doesn't actually escalate, you could be tying up excess funds in a program where those funds could be used for other things, which is potentially detrimental to national security. So we want to make sure we're being as accurate as we can and as reasonable as we can. And again, we use the normalized data as the building block for developing cost estimating relationships, and even our estimates themselves. We almost always start with some normalized cost data to build a cost estimate. So after sitting through this and working through the exercises, hopefully you're able to demonstrate an in-depth understanding of how and when to apply appropriate inflation and escalation indexes, and how to normalize for inflation and escalation, and also able to demonstrate an in-depth understanding of how to normalize for non-inflation data variations, such as quantities or weights, and we went over the software conversions as well as part of the exercise. If you are looking for additional assistance or additional references, there is an inflation and escalation best practices for cost analysis handbook that's produced by OSD Cape, and you can get access to the most recent version of that at this website, on the CADE website. If you do have additional questions or need additional help, I would recommend that you contact your local Air Force Lifecycle Management, FCC office, Cost and Economics office, or your functional chain of command, your supervisor, in order to understand how these things are applied for your specific location, or the best practices that are used at your specific location, because there are nuances and differences that are used based on the types of systems your location acquires. Thank you for listening, and have a nice day.